and welcome to IoT North this week. We've got something a bit special. We are going to be going all, if I don't time this up properly, a bit of Flash. We've got a bit of a Ming talk with Alex. Hi, Alex. How are you doing?
Hi there, Paul. Very well, thank you. What an introduction. Thank you very much for that.
Not at all. We're going to have a bit of fun with this show, I think. Sadly, Marc can't join us, but Mr. Staveley can. Hiya, John. How are you doing?
Yeah, good. Cranking away on IoT. In short, I'm going on holiday at the end of the month, so August is dead for me. I will be enjoying myself. So no meetup next month, I believe, unless you're planning on running one.
I'm not, because I'm planning on disappearing for a holiday, a well-earned rest as well.
In which case, it'll be September. Ingest, query, and visualize IoT streams using Azure Data Explorer, which should be another great talk by Sander, who's spoken with us before.
Excellent. For anybody that's online, please do put your comments in. As always, we'd love to hear from you. Say hi. And any questions, as hard as you like, for Alex, who's very kindly leaning in for Marc. From Balena. Sadly, Marc is unable to join us. Hopefully, he can throw in some comments when he's online, but he's got a family thing to deal with. So sadly, we have not got Marc doing this talk, but we do have Alex. I do need to play one runner in regards to the opinions shared on this show. Our personal opinions and not those of the employees of the host, Intel, for me. This is purely me just arsing around talking about IoT with friends. Alex, you were, first of all, before we jump into it, you were just sharing with us what you've been up to for the past couple of weeks.
Yeah, I'm feeling as though I need to be going away on a holiday now if you two are headed off. I've only just got back. I've been down at the bottom of the Red Sea scuba diving with sharks and other pelagics, hammerheads and manta rays and dolphins and all manner of weird and wonderful beasties. It's been fantastic.
So how long were you out there? Sorry.
Just a week this time. I have some friends out there. I go backwards and forwards. We all get together, have a bit of a dive. We go away on a liverboard boat out of Hurghada for the week, and you kind of live by the bell. It's a very early start. You start about 5:30 in the morning, ding, 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 and you get your briefing, and then you dive and you eat, and you brief and dive and eat, and it sort of goes around like that. And frankly, I need another week of holiday when I get back after all of that. It's absolutely exhausting.
Yeah, I'm not surprised. I'm not surprised at all. Hey, as I mentioned, please do say hello in the comments. We'd love to hear from you. Where are you going on holiday? Let's just open it up nicely on any conversations. Please do say hi. I'm going to get it started there. And John, where are you going to go away to?
I'm going to Annecy in the Alps. My partner persuaded me to go there because I want to go to the north of France because it's melt your brains hot in the south. But she persuaded me the Alps was okay. And I wouldn't actually die from heat exhaustion, so I'm prone to overheating. So I'm going to learn French for a month. So I'm doing French lessons in the morning and then hill walking, swimming in the lake in the afternoon.
Nice.
How lovely. How lovely. Wow. Let's hope we don't get caught in any of those protests, eh?
Don't think there's any near Annecy, from what I've heard.
Yeah, it's a lot of activity going on in France and little coverage in the media, but that's another topic of conversation. Hi, Mr. Sellers. Whose round is it? Well, seeing so you raised it, it's definitely yours. Although I think I do owe Charles a breakfast, actually. Alex, what's the talk about today?
Right then. So as you said, sadly, my comrade in arms, Marc, has not been able to join us. He's had a last-minute emergency and sends his apologies. I am Plan B. I'm going to do my very best to step in and help out with the bits that he was going to cover. So if I look as though I've only seen some of these slides for the first time, it quite possibly is true that I've only seen these slides for the first time. Here we go, but I'll do my best. So Ming is what we started doing was, and I'll go through this in a second. It's going to happen every time, isn't it? My word. What we started doing was we were trying to. I've been working in IoT all my career, embedded systems, and we were looking at some experimentation with sensors and the kind of things that we needed to do with sensor data. And we found really that we needed a kind of a stack, a little bit like what we would have called back in the good old days a LAMP stack, which was Linux, Apache, MySQL, and PHP, or variants thereof. and essentially an enabler to get us going more quickly to do the things that we actually wanted to do, which was playing with sensor data, rather than all the setup in and around it to enable us to do that. So we've been working for quite some time now on some sort of skunk works projects, which have come to be termed Ming. We missed it that time. And that's been taken on by the folks over at Balena, and they've been doing some really interesting work with that. So the first part of this presentation, I'm going to show you a little bit about where this stuff came from, which I'm sure you will identify with from your own engineering lives. And in the second part, I'm going to cover some of the stuff from Marc about what Balena gives us, why it makes life easier, and the kind of stuff that you can get up and running right away, straight away, with a couple of button clicks, should you so wish. So on that note, if I start off, if I close down this screen here, I won't be able to see the comments, so please just flag them up with me if there's anything that anybody wants answering as I go along. So I think you probably have to be of a certain age to get that, don't you? But I'll leave that for your own Googling. Ming. I can find myself the open source lamp-like stack for the Internet of Things. So let's drill down and explore a little bit about what that is. But before I do, the obligatory bit about my business, which is Dynamic Devices. I founded the company down in Cambridge in the early 2000s. We're a small team and we work in a bigger ecosystem of other small businesses. We concentrate on software predominantly in the open source embedded space. And the businesses that we work with, they provide hardware design and development solutions, manufacturing, mechanical certifications. So kind of everything that you need for a sort of soup to nuts design and manufacturing service to bring your amazing, innovative concept through to a commercial reality. And whilst we've done lots of different things over the years, our true loves and my true love is open source and working with various flavors of RTOS and indeed embedded Linux. A little bit about our latest and greatest board, which is very much along the lines described. This is codenamed Jaguar, to be out very soon. It's a secure edge compute device based on NXP's newish IMX8 chip. And what we're going to be doing with this is possibly something for another talk. It's quite exciting to me, at least. This is for a spin out from a Northern Irish university. We're putting these into low voltage substations all over the place and then monitoring and measuring the characteristics of the supply systems there, because obviously there's a lot going on with EV chargers and so on and so forth. And because of the way this is leveraging GPS, we get nanosecond accuracy capturing data, and we can do that with two boards side by side or anywhere across the globe. Which is, I think it's kind of cool, actually. And this board itself is the beginning of one of our first boards, which supports Balena, and I'll explain what that means in terms of secure over-the-air updating as we go along. And we work out of a place called DUS, not all that far from yourselves. I've been involved with the DUS community for about 10 years. It is a fantastic place, so I've always got to give a shout out to the folks there. DUS stands for Doing Epic Stuff, although it's actually ruder than that, but we have to be kid friendly, so it's stuff for these purposes. And DUS was founded really to be an environment where people could go, be a sort of open, supportive, safe community for people to share knowledge and share resources. And so we get all sorts of people going in to the co-location side of it, small business, freelancers. And we've got all sorts of cool workshop facilities, 3D printers, laser cutters, a lot of electronics prototyping machinery that we use, CNC machining. Very welcoming, very open, centre of Liverpool. So if you are around and about Liverpool Way, please do pop in and say hello to us. We are friendly people. Thursday night is open night, and the second Saturday of every month, I think it is open day, Maker Day. You can see all of that on the dusliverpool.com website. So as is the case in any decent engineering establishment, in my opinion, we love our coffee. We have very good coffee, and we source it, of course, from the local roastery. And you can see one of the coffee machines in the picture on the left-hand side. Why is this relevant? Well, Of course, if you're brewing your coffee, you want to know when it was brewed and whether it's still fresh, whether somebody needs to go make another pot. So that's exactly what we did. We've been playing for quite some years with these little devices that you can see in the middle there. I'm not sure how well that's coming out on your screens, but that's a Chinese Sonoff device, which are all over the place now. They are quite literally cheap as chips, and they come in all sorts of different form factors. This particular Sonoff is a Sonoff Pous R2. The Rev 2 is quite important if you want to get these, because it's Revision 2 has an external chip for power metering, which is more accurate than Revision 1, which is fairly useless. So that little thing has got an expressive ESP8266 chip inside it, which comes with some Chinese firmware, which we immediately remove and replace with our own stuff. And that then sits there. It's a Wi-Fi client device. It's monitoring current consumption, power utilization of that coffee pot, and it's publishing that information locally to a local system so that we can work out when the coffee is brewing and when the coffee's been made. So, really critical stuff, as you can see. On the right-hand side, part of our system is that underneath the ubiquitous Liverbird, we have an LCD display there. You can make it out, but it's telling you how long it has been since the coffee was made. And underneath that, just on the corner, you can just about make one of the projects from one of our founders, the Acker's bell, which goes ding, ding, ding when the coffee is ready. And everybody comes out like those little meerkats ready to fill up their cups and grab the coffee before it all disappears. So this is kind of where it all came from. We had an itch to scratch and we wanted to scratch it. And as kind of strange as this may sound, all of these techniques and frameworks that we're looking at are all relevant to any commercial projects. So it isn't quite as crazy as it may seem. So the Sonoff Pous R2 looks like this. Plug in the wires into the mains, chip runs by itself off the mains, and you put it on your local Wi-Fi network. Off you go. Very much dependent on the software that you put on this thing, how far you can get with it. We started out, because we love open source, with a couple of different sort of smart automation, smart home stacks that you may well know of. The first one we looked at was Esperna, which is very good. I think Marc knows the chap behind this, actually. Really worth looking at. Very nice to deal with. You simply flash in a binary into your Sonoff device or other, and up you have a web server. You've got various configuration and administration features to that. So that's great. That said, I have to admit, my personal preference is something called Tasmota, another same thing, smart home, smart automation stack, but it is it's incredibly diverse. It's incredibly mature. I have utmost respect for the people who have developed this stuff. It is really, really good. And, it's one of those things where you're sort of doing some work and you come across a problem and you think, oh, blimey, I didn't realize I was going to have that problem. And then with this Tasmota stuff, they've already fixed the problem before you even knew you had a problem. We all love software like that, don't we? So highly recommend it. I'm going to try and show you a little demo of that shortly. So that's what we've been running on these devices. More recently, we've been moved on to these smart plugs. I can't see the picture, so I don't know if you can see this, but I'll try waving this around. That's a little Chinese smart plug. You'll have seen a lot of these kinds of things on Amazon and elsewhere. There's quite a lot of different variants, and sadly, you can't tell what's inside them until you've bought them. But essentially, the smart plugs we're running with now, they've got a similar kind of power sensing IC inside, and they've got a capability to be jailbroken from the Chinese firmware, so you can do something useful with it. We install the Tasmota binaries, and then we configure it to do power sensing, and we use a protocol called MQTT, which is the M out of Ming. Some of you will undoubtedly have heard of that. It's a standard, ubiquitous, mature internet and embedded protocol developed by a pal of mine, Andy Stanford Clark, and my old boss, Olin Nipper, many, many, many years ago. So I've worked with that a long time and continue to do so. It's all about getting messages from A to B in an assured manner. And it doesn't particularly care about the payload of that message. So it's pretty good for many different IoT purposes. The Tasmota stuff that runs on this, as I say, you can remote control it via MQTT or HTTP, and it also has a local web admin console. Little plug, we are selling these if you want to go and have a look at our Kettle Companion website, where they are pre-jailbroken and pre-installed with Tasmota. which, believe me, if you start doing that for yourself, is not very much fun. So there's a piece that I didn't manage to get filled in from a conversation I had with Marc. He suggested I make the point that you can all do everything from scratch, can't we? We could write all this, we could design some protocols, we could move data around, but it's
we're engineers. Come on, we can do that from scratch, right?
We can
reinvent the wheel.
Of course we can. I don't know how many people want to pay us to do that, but we can do it from scratch. Do we have the energy or the enthusiasm? Well, perhaps not. So, and also, why reinvent the wheel? You know, there's much more interesting things to do solving these problems than to start again from scratch. So instead, what about we look at the kinds of things that we might need as a baseline for a framework to be able to deal with IoT sensors in some kind of system where we look at data and we analyze data. Nearly long enough for me to get a cup of my coffee. So probably stands to reason, doesn't it? We need to get messages from A to B. We need that to be reliable. We want some assured communications. Mosquito is an MQTT reference broker a lot of people use, which enables us to do that. We also need someone to put this data, because we probably kind of want to store it somewhere to look at later on in the day without throwing it away as it comes in. We need some kind of database. Given that we're dealing with sensor data points, we probably want a time series database. InfluxDB is such an open source time series database. Then we've got data, we put it somewhere. What else do we want to do? We want to look at it. We want to analyze it, transform it, move it around. NodeRED is a wonderful Node/JavaScript-based graphical wiring up tool invented by IBM originally. All of this is open source, of course, all of these things. And you can very, very easily prototype up systems and change systems within a web-based paradigm using NodeRED. Then, having faffed about with your data, you need some way of visualizing it. How are you going to do that? Well, we could pump it out to other MQTT brokers, or we could push it out to WhatsApp or telephones or whatever. This is all possible with NodeRED. But for data visualization, we thought that we would go with Grafana. Hence Ming, Mosquito, Influx Database, NodeRED, and Grafana. Now, I should make the point that we're not trying to say here, this is the only way to do this. You know, this is not like the one true way, and please don't take that message away from us here. What we are trying to do is to say, you know, if you're looking at sensor data and doing things with sensor data, you can leverage components like these components to get you where you want to be a lot faster than if you don't leverage them. And what I'll show you a little bit later on, or hopefully Marc will, is that people have taken this Ming concept and they've actually swapped out some of these components for their own preferred components, which is brilliant. It's great to see. So all of that said, and hopefully you're still with me and still awake, I'd like to try and show you a little bit of a real-time demo of some of this stuff working. So I showed you these plugs, didn't I? Well, I've got one of these plugs plugged in here in my space, and I've got my trusty kettle, which hopefully you can see, sitting attached to the plug, ready to boil a cup of water. So we're going to see if we can monitor what that kettle is doing. And the way that we're going to do that is, if I can find the right page amongst all of these millions of pages, I'm going to go to the, this is the Tasmotor web interface on the sensor. So this is the real thing. If I don't know if you can hear this, if I'm try and be quiet for a change. Don't know if you could hear that click, but the thing is that the relay is actually clicking on. You see the voltage go on and off as it connects and disconnects. So that's the plug here. This is a beautiful little thing. Very, very quickly, you can configure it up onto your Wi-Fi network and, you know, do all that good stuff. Then you can configure it up to send MQTT messaging to, in this case, this broker here, client IDs, passwords. You can add TLS to it if you so wish. Lots of other options for this stuff that I won't go into, but it's very, very configurable indeed. And you can change the GPIO layout of the chip in a template manner so that you can put a binary onto one of the many many ESP8266 or ESP32 based devices that are out there to buy, and there's all sorts of different things you can do with them. That ranges from, you know, connecting to other Bluetooth sensors, doing audio, to displays, to you know, the new Matter protocol that's coming out. You name it, this stuff can do it. Absolutely brilliant. So if we go back to the front page and we go back to the, you can see some information on voltage and current and power, which is what we're going to try and move up into the cloud for ourselves. But at the console here, that's just showing you that it's transmitting some MQTT messages up to that configured broker. And if you can manage to see those in here, there is a state message and a sensor message for this particular unique ID of Tasmota device. And that's giving us the information on, say, what the power is at the moment. And it's nothing because we're not doing anything. We're not boiling anything. So those messages are going over my Wi-Fi connection, and they're going up to this Ming stack that we have running in the cloud, which, as I say, Mosquito, NodeRED, InfluxDB, and Grafana. Now, before continuing on with that, what I kind of wanted to do is just touch on Marc's presentation here, where he talks a little bit about where this Ming stuff comes from. Are you with us yet, Marc, by any chance, or?
Sure, here I am. Sorry for being super late.
Do you fancy jumping in and just having a run through of the sort of what is Ming part of your stack and your background before I carry on showing some of the NodeRED flows?
Sure, but just show your NodeRED flows. I think this is amazing. If you can
cool.
share.
Okay, I'll do that.
I'll
do that first then. Well, thank you very much.
Yeah,
indeed.
sure.
So what's happening is that these MQTT messages are going up to the Mosquito broker, which is running in, which you can think of as running in an instance of a set of containers running on a device within Balena. So this is a device that Marc kindly set up for me earlier. It's got a random name assigned to it, Rough Glade. It's part of a fleet which Marc has created. And currently we have this running a number of containers, which are the individual components, the building blocks, if you like, the bricks that build up Ming. So this has got Grafana, InfluxDB, the Mosquito MQTT, NodeRED, and some connection logic. Marc will take you through the ins and outs of this in a little bit. But suffice to say that each of these are Docker containers. They're all running on the hardware. And what you can think of is that the sensor device I have with me is publishing out to an MQTT broker, and then that is being received into a NodeRED flow that I also prepared a little bit earlier. You could talk about this stuff for a long time, and I won't do that. I mean, I know it's the end of a long day for many of us. What I will try and show you is that this is quite a simple flow. There are a number of different nodes that you can graphically pull into your flow, it's called. And, if I want to, say, receive data from MQTT, I can use that node. If I want to receive data from a web request, I can use that node. Here, I have an MQTT node that's configured, to listen on a particular topic, which is Tasmota, that ID sensor. And as I've showed you, that is the topic that we're publishing information on, power readings on. So this is listening to that. And then when that data comes in, we convert it to a JSON object to make it a little bit easier to deal with. And then if you look over here, that JSON object is being logged to a debug output just so that I can see what's going on. And if I open up some of this stuff, here is my JSON object that's being logged. And here is the information that we've got. You can see that there's a power reading and a voltage and a current. Voltage is 244 because that's what it is here. So that information is coming through loud and clear, which is very nice. And then what we have is we've got a little bit of logic to set up the data that we then put into our InfluxDB. And these nodes, power, voltage, and current, are Influx database output nodes. Basically, you send some data into that node and it ends up in your time series database. And it really is that simple. You can obviously do more complicated things, but you can get yourself going, receiving some data from sensors, doing a little bit of transformation of that data as you may need to, and then storing that data very, very, very easily. You know, if I then needed to maybe send that data off into, if I can find it, you know, Telegram, like WhatsApp. If I wanted to send that to a Telegram bot, all I would have to do is pull a node across here, shoot that node into it, configure that node, and I'd be getting messages in Telegram. It's really, really powerful. We all love it. So that is the kind of Mosquito InfluxDB NodeRED side of things. And then just to show you that the information in the database that we're building up here, I'm showing you on a Grafana pane. What do we call this? Dashboard, on a Grafana dashboard. And I've simply got a little power gauge showing power utilization and then some graphs of power, current, and voltage. It is obviously apparent to you that I'm not in the UX designer line of work, and I apologize for that, but you know, I am what I am. So if I put my kettle on now and that starts boiling, you will see, here we go, that the power utilization has started to go up. The sensor is transmitting only about every 10-second intervals, so relatively slow, but you'll see that go up again here now. It's about a 2 kilowatt kettle, so that's about right. And then as you see the power readings go across with the graphs, you know, we're seeing the readings come through from this. So very, very, very simply, we can set up sensors, publishing data through to the Ming stack, and we're data visualizing what we're doing here. And then we can pass on that data into many myriad different forms for different third parties as we may wish to. For those of you who may not have seen Grafana before, I don't want to leave you with my very limited graphical abilities. So I'll show you this rather nice little node exporter dashboard, which you can download from the libraries. I've got that running with some export tooling on one of my cloud servers, which is running all of this. And it's just showing you, you know, the usual stuff, CPU, memory information, and really, really pretty impressive stuff. You can do a lot with this. I'll go back and I'll say, just to close this piece, that doesn't necessarily have to be InfluxDB or even NodeRED or Grafana. And lots of people we talk to have their own preferences. But this is really just about getting you going with a lamp-like stack so that you can do what you want without having to fiddle about too much with the underpinnings. And I think Marc is going to come on now and tell you just how easily all this can be set up if you're using something like Balena.
Indeed. Yeah, that was great to show this, I guess. Yeah, I don't think I want slides. Maybe just leave your kettle boiling if you want, or I can share my screen in a sec. But okay. Actually, first of all, like a disclaimer, I don't know if you published this disclaimer before, but when Alex, like a year ago or a year and a half ago, told me about the Ming stack, he gave me an interesting comparison, and he asked me, "Did you learn programming using the LAMP stack?" I don't know if anyone on the chat right here listening to us use the LAMP stack, Linux, Apache, MySQL, and PHP, or Python or Perl, or whatever variation you use. Or instead of Linux, I actually use it with Windows when I learn about the LAMP stack. Anyone here? Let's wait some second. But actually, what actually engaged me with the Ming stack was what Alex told me. Like, this is like LAMP stack for IoT. So, actually, yeah, that was a great analogy, I guess. And I think LAMP stack helped a lot of people that was not web developer to get into web development. And we actually think that the Ming stack can get a lot of non-IoT developers into IoT development. So you don't need to start from scratch. So you can see how easy, or Alex just show how easy it's to don't start from scratch when you get data or HTTP or MQTT data from a Chinese device like the Tasmora he was demoing some seconds ago. Just with the flow from NodeRED and Grafana, you can have everything up and running. I'm not sure if the chat is related to the conversation or not, but feel free to. I try to buy elsewhere. Okay, thank you. Let us know what do you buy. because AliExpress is so slow. Okay, so as a disclaimer, so I work at Balena. Balena, it's a company that helps to manage a lot of IoT devices and to allow you to run the same software, so to update the software running on IoT devices, basically that they run Linux on these IoT devices. So when Alex was explaining about the Ming stack, I thought that this was like a perfect boilerplate project for developers to get started on the IoT. So I started hacking some containers, etc. Because at Balena we use containers on IoT devices, and then we started to play with the Ming stack, and actually I realized that a lot of developers are using the Ming stack already on their IoT stack or on anything else. I realized that the Ming stack is very well used on industrial IoT projects, but as well on other type of projects that I'm going to show you in a second. Okay, but if you want to, okay, see Matt saying we use a similar stack on Balena with InfluxDB, MQTT, but Home Assistant in place of NodeRED. That's a good one. So I would like to finish showing you some stacks that are that philosophically start as a Ming, but finish on something else as these, right? So it's Home Assistant, MQTT. I don't know what this would be like. Mic. I don't know if you use Matt. Do you use Grafana or not? If not, it's like me, right? Or I don't know how you pronounce it. So yeah, I'm going to show you how other companies or developers from the community actually evolve the Ming stack to something else that is useful for them. At the end, what we want is just to help any IoT developer to reduce the friction when they do IoT projects. Just to add on the disclaimer that I work on Balena, and actually Alex is a Balena ambassador, is that everything that we are going to show you here will work on any Linux operating system with Docker. Okay, we're going to show.
And what he should be saying to you is it will work with one click. One click. It's right. Isn't that right, Marc? One click.
Please go and show the slide that I like, the diehard slide, please. But yeah, so what we try it's really reduce friction. So in one click you can deploy the software on IoT devices. And why? So actually, this is actually when Balena was created. I don't know if anyone here used Resin.io, was the previous name of Balena, or actually the goal was like at that moment, like 10 years ago, changing any bug or any typo on websites was kind of easy, but not if you had an IoT device. It was really hard to update the software of IoT devices. So this was like the motivations, like updating the software of IoT devices should be as easy as changing anything on a web. Right, and this is actually what we are trying and getting inspired by a lot of web frameworks or web systems or platforms that manage websites. So this is what we do at Balena, basically. All right, so we have Grafana only on the server. Okay, running Influx locally. Oh, really nice. And Home Assistant for local dashboarding in the home. Yeah, sure. So actually, this is super interesting, Matt, because so at Balena, basically most of our customers, so what they try to focus is running Balena on the edge for the edge computing. But then, of course, architectures can be more tricky. I will show you as well another architecture where we have Ming stack for industries on the edge. But then the MQTT broker, the local MQTT broker, actually has a bridge extension with a cloud MQTT broker, where actually when you want to scale the Ming stack, you need something central, right? That gets all the data centralized and can be visualized with another system. I'm going to show you these as well in a sec. So yeah, let's go now to show some demos. Some of them are broken, some of others are working. Sorry. But let me share screen. All screen. Yeah, this is it. So Freya Miner says, we are using homemade MQTT like with Google PubSub messaging services and custom edge devices. So, wow, what do you do with this? What do you mean by homemade MQTT? With Google PubSub, okay. Yeah. But you mean that in the edge devices you created your own MQTT broker? What? Oh, whatever. I'm trying to share my screen, Paul, John. Yeah, thank you. Thank you very much. Okay, so maybe let's explain how to get in here before. Okay, so at Balena, as I explained before, we have different tools. Our goal is basically to enable any IoT developer to update the software running on IoT devices, but as well update the operating system running on IoT devices. When I talk now about IoT devices, I talk about IoT devices that can run a Linux operating system on it. Okay. And basically, yeah, we help companies with thousands of IoT devices deployed all around the world. Okay, and they need to, the software, you need to, you have new feature requests, you have bugs, so you need to update the software, but as well the operating system. Okay, this is something that every day I'm more and more surprised that companies don't care about updating the operating system of their IoT devices. I'm like, what? So what is Balena Hub? Oh, well, yeah, to run Balena, we have an operating system based on Yocto called Balena OS, which is compatible with more than 100 different IoT devices. And then on the top of Balena OS, this operating system only can run containers. So you cannot run anything on the host OS. Why? Because something that I said some minutes ago. So we were inspired by web developers. So we have we think that, if tools like containers are being used by the web development, this means that they make a lot of sense to don't allow any developer to run anything on the host OS of an IoT device for security reasons. And actually, running containers on IoT with Balena OS don't add any overhead on the device, so it's actually almost the same than running it on the host OS. Okay, so you can have a device with multiple services running on the IoT device, and that are interconnected and get published on different IP addresses or on the same IP address on multiple ports. And on the top of that, we have Balena Cloud, or we have Balena OS and Balena Engine, which is our Docker engine based on Docker Mobi. They are open source. And we have Balena Cloud, which is our premium account where you can connect up to 10 devices for free. Or you can use Open Balena, which is actually the same, open source. So we have a full stack open source, or you can use our premium tool, which is Balena Cloud. And on the top of that, we have Balena Hub, which is a marketplace for applications. So you as a developer, you can submit your Balena application here, and anyone can go and just deploy it on an IoT device. Actually, one of the application, if you go here on keyboard, it's main. Okay, so I have here, my name is Marc Pous, and this is the main application. Actually, this is usually, you can deploy it on Raspberry Pis, and you can click View Code, and you can access to my GitHub repository. Okay, where you can read more things. You can also, if you see these blue buttons, deploy with Balena, actually as well, will deploy the source code or this Docker Compose actually on your repo. For people who knows Docker, probably knows as well Docker Compose, which is what you need to deploy multiple containers on. It's a template to do that. And basically what we run here, it's a service called Wi-Fi Connect. Wi-Fi Connect, it's a service that in case that your device doesn't recognize any Wi-Fi on your environment, it gets into hotspot mode, so you can connect with your mobile phone and set up any Wi-Fi credentials and get connected to the internet. We have NodeRED, as Alex showed some minutes ago, InfluxDB, Grafana, and MQTT. Okay, the Eclipse Mosquito. All right. So just to deploy it, just click on Deploy with Balena, or just click Deploy, and that will open Balena Cloud. If you don't have an account, you just created, say, 10 devices for free. If let me share this here on the chat. Maybe I'm not sure if I can publish. Yeah, awesome. or yeah, you can click View Code and you will see it. Okay, so I have here one device, which is a Raspberry Pi 4, but it's struggling with the memory, as you will see in a second. And basically, I can explain this project. So I have a solar panel with some charge controller, an inverter, and a battery next to me. I cannot show you the mess that I have with cables, etc. here. But basically, so one Balena ambassador as well published a container based on the SDK of the charge controller that by serendipity I also had at home. So I wanted to see the data generated by my solar panel and the battery, etc., etc. And I said, okay, so I can develop everything from scratch. Or I thought it twice, and then I decided maybe I can add the main stack on the top of this called Tronmon. Actually, let me show you. This is a project from Christopher. So what I did basically, it's okay, this is one container, so let me put the main stack on the top of it. And basically we have Tronmon, Grafana, InfluxDB, MQTT, and NodeRED. And yeah, basically what we can see, oops, I don't have it open, but on the port 80, we can access to the NodeRED. Fingers crossed that everything works. I had some problems with this device today. But what we are going to see here is that we get the data from the USB 0 port from my Raspberry Pi, which is here on the, it's this Raspberry Pi next to me. This is connected over USB to the controller. And basically, we have a function to parse the object that we get from USB. And basically, we publish, we don't publish it to we get, okay, so the device sent the data over MQTT, we parse the object, and we just store it on InfluxDB. And then we have this Grafana dashboard that it's actually checking the data. I don't know if I turn off my inverter, I don't know why it doesn't showing data. It's a bit slow. I think the RAM, it's so full. I have to restart the device or something. But yeah, maybe we could see as the kettle from Alex demo. But yeah, so it's that easy, right? So you don't need to reinvent the wheel just to visualize data in real time. You just can get everything up and running in just adding some extra containers. And basically on Balena, if I'm not wrong, this is on Solar Panel Victron. So basically what I did, it's add NodeRED and Tronmon here, Eclipse Mosquito, InfluxDB, NodeRED, Grafana, and it works. Okay, let me share it on the chat. I think I will go to the chat. Okay, I will try to go fast. So then on conversations with other people and other developers from the community, they were saying, yeah, sure, we use Ming stack, but we didn't know that that had a name, right? So some people just use Min and then use Grafana, or use Grafana on the cloud, right? Others just use something else. So let me show you some examples of other developers who are building something like that. Let me go here. So actually, yeah, no, let's go here first. So this is, yeah, let me give some more context. This is, sorry for this. So we have this project, actually, yeah, let me show the architecture, basically. So basically, this is a gateway that I have at home. So we get data from PLCs over Modbus or OPC UA. NodeRED just makes the magic. And NodeRED just publish over MQTT. Instead of Mosquito, we have HiveMQ, because the customer needs HiveMQ in this case. And the customer has multiple of these gateways in different places. For example, this is in Munich, in Germany. Mine is in Barcelona. And then we use InfluxDB and Grafana as a local historians and a local dashboards for each one. And in this case, there is a HiveMQ cloud instance that connected over the bridge extension from HiveMQ can get the data. And then actually there is a data cake instance subscribed to this cloud, or anything subscribed to this cloud. and just visualize the data. Let me share this on the chat as well, just in case that anyone wants to read about it. But this is just a variation. Instead of using Mosquito, start using HiveMQ. But then the next iteration of this, that it's still not public, it's this. So instead of using NodeRED, so other developers told me, hey, why don't you use a more professional tool instead of NodeRED in the industry? So why don't you use Ignition Edge? Sure, why not? So this is what we are doing here. So instead of NodeRED, we use Ignition Edge, which is free for 2 hours, and can read Modbus, OPC UA, and a lot of as well industrial protocols. And basically, it's exactly the same. So you have these in the edge, and actually Ignition Edge just published over MQTT Spark Plug B, which this can get for another episode of the meetup, over a central MQTT broker from Ignition or another MQTT broker to unify all the data. And then, yeah, it gets visualized from a cloud Ignition or from another Ignition device. So this is a variation 1 that we can see. Actually, another community just contact me and say, hey, so why don't you use for industrial IoT, instead of using NodeRED from that blog post that I showed you before, why don't you use something else? And basically, instead of InfluxDB, we use as an historian MongoDB. Awesome, yeah, let's do it. And there are like iterations of this Ming stack that basically transform the services that are running on the devices, but basically the spirit is actually the same. So you have a PubSub protocol like MQTT, just to have like an event-driven architecture in the edge or in the cloud. Basically one service, which is basically transforming the data and collecting the data and transforming the data. Like in this case, it's Neuron, but in the other case was Ignition Edge or NodeRED. And you have a local database, in this case Mongo, but you can have InfluxDB for time series. Well, Mongo you can maybe use as well for time series. And then something to visualize. In this case, for visualizing, we also use Neuron, but you can use Grafana or something different. Okay, Neuron is as well free for 2 hours. And what else? Yeah, and I have as well another device here for visualizing Modbus data, but yeah, it didn't work, so I'm not going to show any failure on this demo. So basically, this is it. And by the way, yeah, there is another developer from the community, which shows something super interesting, which is, let me try to find the link. Well, yes, this is super interesting. Let me put it here. So this is, I don't know if there is any fan of the LoRaWAN, of LoRaWAN networks here in the community. Please raise your hands in the chat or clap your hands. But yeah, this is actually something super interesting made by Jose Perez, which is a superhero of LoRaWAN networks. And it's basically, if you have a Raspberry Pi with a LoRa concentrator that can be attached on the Raspberry Pi, basically deploying this Docker Compose with Balena, or as said before, with the Linux operating system and Docker, you basically are deploying the things stack, the community edition. You are deploying the basic station packet forwarder. You are deploying the Wi-Fi Connect, which is super interesting to have, or super important to have, NodeRED, InfluxDB, and Grafana. So what do you have here? So you have a LoRaWAN gateway that is running all of the things stack, the LoRa network server stack on it, and all the Ming stack. So you have actually you can set up a private LoRa network, a LoRaWAN network server, and a LoRaWAN network, basically, just on one Raspberry Pi. So you only need one Raspberry Pi to create your own private device, and just accessing to this device, you can visualize the data generated by all the sensors that send data to that private network. So this is super incredible and super amazing in case that you are interested in setting up private LoRaWAN networks. Let me share it here as well for the interest of anyone. And what else I wanted to share? I wanted to share something as well from a developer from the community. Here it is. This is a gist. I'm not sure this is there is any repo about it, but we had this amazing developer from the community called Alex from the north of Spain, and he sent me a message on the Balena forum saying, "Hey, we don't do Ming, we do Mint." And what is Mint? And he said, "Yeah, Mint is MQTT, InfluxDB, NodeRED, and ThingsWord." And sure, can you share me the Docker Compose? And this is it. So this is as well. So they like to visualize data with ThingsWord, and this is what they do. And basically, you can see the Docker Compose in case that you want to deploy it with everything that you need with ThingsWord here. And let me share this to you in case that anyone is interested. So you have here multiple flavors, multiple projects, from industrial IoT projects to LoRaWAN projects. Where the Ming stack, it's something that it makes sense to quickly visualize the data, analyze the data, store the data in the edge, and help a lot of developers instead of reinventing the wheel and making everything from scratch. And this is it, I guess.
I have some questions. If there are any other questions, please put them in the chat and we'll discuss them live. So Alex, you said it's one-click deployment. So let's say I've got a Nordic Semiconductor device or a Raspberry Pi, out the box. How would I then get the Ming stack on it? Because if it's Docker containers with Docker Compose, I don't have a Docker hub running on that all the time. So there's some pre-steps there.
Yeah.
And also with the Balena scenario, presumably there's an onboarding process you go through that installs some kind of daemon.
Absolutely. I was perhaps being slightly facetious, but it is, it may not be one click, but it's pretty easy, and I have a privilege of being the Balena ambassador, but I'm in no way affiliated other than that with Balena, so I feel I can speak independently. And basically, I'm involved with what Balena do because I really like it. It makes my life easier, and things that make my life easier, I really like. I've been working with Open Embedded Linux, Yocto Linux for, since before Yocto was created in around 2010. And a lot of the trouble I've had is because of the standard desktop package management system with packages, with dependencies on packages, upon packages, upon packages. And that I found caused me immense difficulty with maintaining remote embedded systems, and 10,000 embedded systems in the field. You're trying to manage all these packages, upgrade releases of Yocto, keep control of that, ensure you're not going to break devices. It's quite terrifying, really, or terrified me. Others may have solved that problem, but I had a lot of trouble with it. I didn't feel that in the world of Linux, we can realistically be doing A/B firmware image switching when we're talking about these very large sizes of file system. So you're kind of stuck. And then, one bright, shiny day, I was at an embedded Linux conference in, it was Dublin or Edinburgh, and I bumped into these people, resin.io, since renamed Balena, and they had this weird idea of taking Docker containers out of the cloud and putting them onto embedded systems. And I thought, what's all that about then? And they explained it to me, and I kind of had a light bulb moment. And it was because the pain I was having for years trying to maintain and worry and keep these systems updated, and this is even before security became the touch point that it is today. I could see that if I could abstract away a base layer that we very rarely touched from a set of not simply application binaries, but complex containers of applications, and I could just lift them off or pop them on to a remote system, literally with a button click. Well, that was cool. That was really interesting. And I wasn't going to leave any dependencies behind. I wasn't going to leave dangling links or damaged files or things I'd forgotten somehow to clean up, or some third-party package manager had forgotten to clean up. And that was a really, really big thing for me. And I mean, I've been sort of following the progress of containers in embedded for a long time, and particularly the great work Balena are doing. And I really like it. And again, it's because it works and it makes life easier. Now, to sort of go back to try to quickly answer that question, yes, you need to get a core binary that's, you know, the bootloader, the kernel, the file system. You need to put that onto your board platform. That needs to be supported. You know, maybe that's a Raspberry Pi, maybe it's a custom board, maybe it's an emulator. That has to be there to begin with. But once that's there, and you know much more about this than me, Marc, so you correct me if I'm wrong, but you need to onboard this system. So you need to onboard it into a fleet within your Balena ecosystem.
Right. So Balena is definitely part of the solution. I can't do Ming without Balena.
Yes. Oh, absolutely, you can. Yeah.
Yeah. Okay.
And one of the, I don't know if Marc actually made that caveat, but he made it clear to me. We should be very clear that all of this is open source and all of this is entirely doable in isolation. There is absolutely no requirement on any kind of Balena for this. You should be able to deploy it now onto any Docker container system you like. And if you had to, you could put all those, if you wanted to take it back, you could put all those components and mash them together onto a pre-built image for somebody. But my argument would be that would be a bit of a backward step, but you're not hooked into Balena.
Right, so Raspberry Pi, Docker machine, Docker Compose up, and I've got my Ming stack.
Absolutely. Cool. Or Mint or whatever it might be. Who knows?
Yeah, absolutely. So yeah, everything that I show is compatible with any Linux operating system. You can set up a virtual machine if you want with Linux, with Ubuntu or whatever. Just install Docker, and that might work there as well. Yeah. On the other hand, I know developers who are running NodeRED, Grafana, everything on the host OS as well without containers. But my recommendation is don't do that. Because,
just to sort of jump in with a little example that came to mind in that sort of one-click conversation. So I was at Liverpool Makefest on Saturday in our central library here. Lovely day, really interesting, eclectic mix of people. I was trying to do a demo of some video collateral that we had for the bench that we were on, and I had a Raspberry Pi and a HDMI screen. And that Raspberry Pi was a member of a Balena fleet that I was doing something else with. I can't remember what. It was doing some kind of display. And I thought, oh, bugger, what am I going to do? And I quite literally, I just clicked a button to move that device, the sort of logical device within the Balena environment, through to a different fleet. And automatically, it just threw away all of the old containers that were doing what the original job was, and it downloaded the new containers. And admittedly, I had to change a variable URL because I wanted to show a particular YouTube video, and boom, it just worked. And it's kind of this, it's this kind of next step of configure up a fleet, if you like, a system to do what you want with your Docker Compose, leave it there. And then, if you ever need a device to do that stuff, boom, throw the device on it and it'll just sort itself out. And I know there are other ways of doing these things, but I really like that.
So the Balena piece is, I've got a daemon on the device. I can then do a push commissioning from Balena, and then it will set it all up. And then I'll be able to do that to multiple devices across my fleet with bespoke parameters for each device.
So sort of in a business type of thought here, right? It's about enabling you with scale. In regards to you creating your blueprints, test and try it out with your configurations, and then you want to deploy it out to numerous devices, and it may be for different fleets, so on and so forth. It just makes that whole remote access and management side of things and deployment much easier, yeah? So then, in regards to the challenges with IoT, in really getting it out there, it's one of the key areas that can help that happen by just that replication of.
And I'm thinking, I'm sure we've all had similar things and problems I've had. We've got a new software release. How do we get it out there? I know of people who've pushed it all out at the same time to all 100,000 devices, and many of them have then stopped working. We'd, of course, be more sensible. We'd probably have a number of fleets, and we'd push the new version to a smaller fleet or a subset of the fleet. check how that goes, see how that works. Maybe that's a friendlier customer. Brilliant. Okay. And off we go, and we widen out. Or, we've done an update. Something happened on a Friday night as someone was rushing off to get out of work and they buggered everything up. That update's gone out. It failed. It shouldn't have failed. It couldn't have failed, yet it did fail. But because we've abstracted this stuff into a container and the management system is abstracted out and isolated, we can push a button and roll it back.
Yeah.
Now, that's not a unique
huge,
thing,
right?
but it's nice to have, isn't it?
Yeah.
One click away.
Otherwise, you end up pulling your hair out.
Basically, just to resume the hierarchy, you just create a fleet, the concept of a fleet. You just deploy the software that you want to run on all the devices that will belong to this fleet. So you just send this Docker Compose, Balena builder, just build that images for the devices. And then you need to download the Balena operating system. You just install flash the operating system on the devices that you want. This operating system has a config file that says, hey, you belong to this fleet. And then each operating system has the daemon that you mentioned, which is we call it supervisor. And the supervisor basically is in charge to ask, is there any new update for me? Is there any new update for me? And also brings a VPN and on other services. And this is what we do, basically download the latest release or the release that you say that you want to run, or change to another fleet, as Alex did during the weekekend.
Yeah.
Hey, sorry.
So one last thing, Alex, and then we're going to have to wrap up. We usually wrap up. We're 2 minutes over.
The other thing, that is as embedded people or IoT people, we have lots of things to worry about. It's very hard what we do. I worry a lot about security now. I think there are a number of elephants in the room that people aren't talking about with security now, and one of which is that we're obligated now to keep devices that we provide secured through their lifetime. Not perhaps the easiest of things to do with an LP1 connection to those devices. So how are you going to keep it secure? How are you going to manage your fleet of devices if 0 days come up? Who's in charge of that? Who in the company is going to fix that? How are you going to deploy that to 100,000 devices before it hits Twitter? These are really scary things. And I posit, again, with no commercial involvement, that if you offload that problem to a platform provider who manages the updates for you, you can get on with the value that your business is providing with your innovations, and let these other people get on with securing your updates and managing your secured platform. And I that's the kind of world I would like to live in the future, because I can't see us all trying to secure our own platforms for our own devices all the time, or as you say, their hair will be gone.
Yeah, and with the new EU legislation coming out, that has teeth. So, there'll be some fines if you don't do it.
Yeah. And just an extra recommendation on the top of what Alex mentioned. So my recommendation with the years of experience that I have is, don't get into a system that lock-ins your product. So try to embrace as much as possible open source or this type of tools. And this is why, using something that uses open source or has a open source stack will give you as well freedom to change if you're not happy, but if you get into a lock-in system, that can be painful in the future for you.
I think that's what we're seeing with the market, though, isn't it? Like there's some proprietary systems out there that are not scaling and growing in the market as they did initially. And I think it is that thing of businesses are recognized and they don't want to be held to a proprietary system, that actually leveraging open source like Balena and EdgeX Foundry and so on and so forth, that you can work with a company that commercializes it and puts support and stuff around it. But if that relationship doesn't work, you're not left stranded. You can easily move to somebody else that can pick up from where they are as well. I've definitely seen that shift in the market. Remember, once upon a time, I represented a proprietary system. I don't anymore. But any case, hey, thanks very much. Great chat. I don't know if Marc saw when we first joined, but we all went Ming at the beginning.
We're going to change the logo of the application. We are working on that.
John, we have a talk. So holiday for August for you and I. September, we're back. What's the talk?
Ingest, query, and visualize IoT streams using Azure Data Explorer with Sander van der Velde, great speaker we've had before. So look forward to seeing you all there. We'll publish the event in the next couple of days.
Excellent. Thanks very much. As always, this show and all the others are available on our websites, YouTube channel, and LinkedIn. Marc, Alex, thanks very much. Absolute pleasure. Great talk as always.
Pleasure.
Look forward to having you on again. John, thank you very much, my friend. We will catch up soon. And if you'd like to get in touch, I am info@iotnorth.uk. And on that, I'm going to wrap up. If I could get my computer to work properly.
Have a good day. Have a good
Thanks very
weekend.
much.
Thank you very much, guys.
Good night.
Good summer.
Thank you very much. Cheers.